All right. Hi, everyone, and welcome to today's webinar, Delivering Edge to Cloud Digital Resilience for OT. I'm Greg Leonard, and I'm here with Adam Rigby.
Hey, everyone. Great to be here.
And before we start, I'd like to touch on a couple of administrative items. First, the webinar is being recorded. And second, everyone is on mute, and we would like to encourage you to ask questions. And to ask a question, please do so in the Q&A panel on the right-hand side of the WebEx event application. If you don't see the Q&A panel, please click on the three dots in the lower right-hand side of the WebEx event application and choose the Q&A panel. The panelists will try to answer your questions during the webinar, and if there's time, we'll have a live Q&A towards the end of the webinar. In any case, we will respond to all questions, and after the webinar, these will be made available to you along with the webinar recording. So today, we're diving into the critical topic for manufacturers, digital resilience. We're going to break it down into three key areas: connectivity resilience, cyber resilience, and data resilience. We'll also be hearing from two other industry experts, Ravi Subramanian from HiveMQ, who will talk about data resilience, and Johan Jepsen from Orange Business, who will talk about why digital resilience is so important for Industry 4.0 use cases.
Yeah, it's great that we have Ravi and Johan here today with us, Greg.
It sure is. And Adam, before we get into the details, let's level set. I mean, what do we actually mean by digital resilience? It's a bit of a buzzword these days.
Yeah, it certainly is. So in a nutshell, digital resilience for OT is about ensuring your operations can withstand disruptions, whether they're caused by network outages, cyber attacks, or data loss. It's really the combination of three key things: connectivity resilience, making sure your systems stay connected; cyber resilience, protecting your systems from threats; and data resilience, ensuring your data is reliable and available. Digital resilience will ultimately help manufacturers deliver better business outcomes and improve their KPIs.
So it's about being digitally robust across the board. Got it.
Yeah, we've got a packed agenda today, but it's all about helping you ensure your OT environments are super reliable, secure, and data-driven.
Exactly. So let's jump right in. Adam, maybe you can kick us off with connectivity resilience. After all, you can't have digital resilience without connectivity resilience. So what does that really mean for our manufacturing customers, and what are the key challenges they're facing?
Great question, Greg. Well, for manufacturers, connectivity resilience is all about ensuring that their critical OT assets and systems, PLCs, AGVs, sensors, robots, all that stuff on the factory floor stays connected and operational, no matter what. We're talking about minimizing downtime, maintaining production flow, and ensuring that data is continuously available to the applications and dashboards that require it. So let's look at these in more detail, or OT digital resilience in more detail. Here are some of the business imperatives. To start with, manufacturers want to maximize uptime, improve quality of the output, reduce any waste, and increase the yield. At the end of the day, you need to ensure that your production keeps moving forward. Secondly, they need to maintain and improve worker safety. The number one priority for every company today is keeping their people safe. Thirdly, with digital resilience, you want to leverage new technologies like predictive maintenance, AI, and machine learning. For example, we are seeing innovations happen in this area today. Digital twins and virtualization are also becoming more prominent, not only of the HMIs, but also now experimenting with virtualizing PLCs, and not to forget network automation. Finally, sustainability has to be top of mind as companies are continually pressed to meet the net zero targets, as well as reduce operational costs. All of that requires a managed, resilient, reliable, and well-performing and secure end-to-end network based on industry standards. So let's dig into that a little bit more on connectivity resilience. We need proven designs that are repeatable. They've been tested in various use cases and are scalable to meet small and large deployments. They need to be reliable. What we mean by that is having reliable products, services, and partners. Purpose-built for industrial use cases with industry certifications. I can't stress enough how important a long-lasting partnership is with both your vendor and your implementation partner. Lastly, we need assurance, ease of management in a single pane of glass, and being able to automate processes effectively and efficiently. Lastly, assurance will give us the assurance that our systems are doing what they say they're doing. to comply with our compliance reporting obligations. And lastly, having troubleshooting tools to be able to get us to that mean time to resolution as quickly as possible. And that's pretty much how Cisco helps ensure connectivity resilience in OT environments. Lastly, with regards to connectivity resilience, on the physical component side of the factory floor, we've got robots, I/O drives, and sensors. These are all communicating with the brains of the operation, which resides in the data center. That might be high performance virtual compute, virtual PLC, and virtual robot controllers. Critical to all of this is the central nervous system, which is the network. And that's where Cisco comes in.
Awesome, Adam. That was great. I think the key takeaway is that the network is fundamental. It's the nervous system of the factory floor, and you've shown how Cisco ensures that that nervous system is always functioning.
That's right. So we've talked about the importance of reliability in OT networks, but what about security? Greg, what's the story with cyber resilience in OT environments? It seems that's a constantly evolving threat landscape.
You nailed it, Adam. Cyber threats are a huge concern, especially in OT, and it's not just about protecting data, it's about protecting physical assets, processes, and even people.
So what are the key things that manufacturers need to be thinking about when it comes to cyber resilience?
Well, visibility and understanding the security posture of OT assets is key, and so is segmentation. In fact, having a zero trust approach is now where OT networks need to move to. It's about understanding what assets you have, who's accessing them, and what they're doing.
Okay, that makes sense. Well, let's dive into cyber resilience section. Greg, do you want to take it away?
Thanks, Adam. Yeah, so let's take a look at why OT cybersecurity is such a hot topic. 20 years ago, these OT systems and networks benefited from security via obscurity. You had to really understand the weird and wonderful industrial protocols that were in use in order to cause any serious damage. Over time, that has changed. Bad actors are better equipped to infiltrate these OT networks, whilst the networks themselves have largely remained the same in terms of security. And it's sad to consider, but there is hardly a month that goes by now where there isn't a major cybersecurity attack that shows up in the media. And the recent changes in the geopolitical situation is likely going to make matters worse, unfortunately. But not to fear. There is hope, and there are security tools out in the market today that will significantly help protect against and to mitigate OT security threats. And all cybersecurity vendors out there have their own ways of offering customers value for protecting their OT networks. And Cisco has its own approach, which I think is unique on the market. So we look at network as a fabric to secure the OT at scale. We embed security into that fabric by layering in software. So for example, if you want OT visibility, we embed that into the network equipment. If you want zero trust network access to OT assets, well, guess what? Again, we layer that software in and we provide a gateway from a software perspective embedded in the network equipment. What about segmentation remediation policies? Well, again, we're using the network there to enforce it. So security is embedded in the network fabric. That's what we want to do in Cisco. And we try to make that easy so that we can scale that. We want to try and avoid spanning traffic and introducing things like mirror taps. We don't want to have bolt-on security controls. And we certainly want to avoid any extra hardware because that's just extra cost to maintain. And that takes me to Cisco's industrial threat defense model. This is actually a part of one of our Cisco validated designs. There's these three pillars in industrial threat defense. The first one is visibility, and that is OT asset visibility, understanding what's on your network, how they're communicating with each other, and what its security posture is. That's what Cisco CyberVision does. Again, Cisco CyberVision is embedding their sensors into the network equipment themselves. The next pillar is protection, and that's zero trust security for OT. There's kind of two aspects to that. So first of all, you've got secure remote access, which is a continuing challenge for manufacturers these days. A lot of times manufacturers are having to use always on VPNs, and that causes a lot of extra IT kind of efforts to keep those secure. The other approach that's used today is adding in extra hardware, like an LTE or a 5G gateway. And that again causes its own problems and headaches for OT and IT. However, secure equipment access, we have a very different approach. No extra hardware needed. We're embedding it into the network equipment itself, that zero trust network gateway. The other aspect to look at is segmentation and zone segmentation and creating smaller zones of trust. And really key in this story is again cyber vision, which is getting all that rich information of the OT assets and their vulnerabilities and sharing that OT context with systems like Cisco's Identity Services Engine, which is the network access control system. That's where you can define your security policies, and that pushes the enforcement down into the network. Also, Cisco CyberVision shares that OT context with Cisco Secure Firewalls. So we get that dynamic nature of being able to reflect the changing nature of an OT network, which Cisco CyberVision picks up, and that's shared with other systems out there like ICE and Secure Firewall. Finally, there's detect and response. And what's important in that particular pillar is to look at things cross-domain. And I call that a cross-domain security operations center because it's looking at IT and OT. You can often see that sometimes a problem and an event that happens in IT could end up being a problem in OT. So you need that cross-domain visibility. That's exactly what Splunk gives you. Splunk receives inputs from not only Cisco tools like Cisco CyberVision, ICE, Secure Firewalls, Secure Equipment Access, and other Cisco security tools, but also third-party tools provide inputs into Splunk, giving you that visibility across the entire attack chain. So once again, we're using the network as a fabric to secure OT at scale. So let's take a little bit of a closer look at Cisco CyberVision and how that can help to manage risks from OT assets. And it's really giving that full visibility, and it's doing that through the deep packet inspection that's happening at the CyberVision sensors, which is embedded inside of the network equipment. And those sensors are able to pick up the different assets that are communicating on the network. And then because we get that detailed information about those assets, we're able to do security profiling and find out what the asset vulnerabilities are. We also combine those communications and what the assets are and how important they are and the vulnerability information to help build up a risk score to help those OT and IT people define what their first steps should be and what their greatest risk areas are and where they should focus their efforts. The next tool that we've got and the Cisco Secure Equipment Access, which is really the ability to provide secure zero trust network access to remote access to OT assets. And that again is around embedding that zero trust network access gateway as a bit of software that we put into the Cisco switch or the industrial routers right at the very edge where those assets are connected. Now at the zero trust broker, that's kind of the centralized tool where the manufacturer will go in and define the policies to allow the remote access for the remote users. And the idea behind that is that it's always with a zero kind of trust approach with denying before allowing anything to happen on the network. And the strength of this particular tool is that you can schedule when these remote access should happen, the day and a time. You can also record the sessions. You can monitor them live as they're happening. And of course, when it's over, you have full security logs for compliance reasons. There's also the option to do session approval on request. So that's really how Cisco helps to protect OT environments from cyber threats.
That's great, Greg. I think that really highlights how critical it is to have a layered security approach in OT. So we've covered connectivity in cyber, but what about the data itself? How do we ensure that the data from OT assets is normalized, reliable, and available to the end applications that need it? That seems especially challenging in industrial environments today.
Well, that's where data resilience comes in, Adam. And we just happen to have an expert with us and who's going to walk through that. So I'd like to introduce Ravi, the Director of Industrial Solutions at HiveMQ. Ravi, over to you.
Thank you. And if I can take the share here, if you don't mind.
Please do.
I can share my screen here. Give me 1 second. Yes, share. Yeah. Do you see this come through? I'm going to move
Yes, we
this
do.
to slideshow real quick.
We see it fine, Ravi.
Thank you. Thank you. Thanks, everyone. Thanks, Greg, and thanks, Adam, for the wonderful introduction talking about digital resilience and then like OT, cyber resilience, which is absolutely important. So as you mentioned, I'm going to be talking about like the data itself, right? So obviously, there are a lot of things related to data where OT systems kind of like have issues with that need resilience. And that's where OT data resilience really comes in. You have industrial environments are like unreliable for the most part. Like you have like remote plants or legacy infrastructure that can potentially cause data loss. And real-time data decision making depends on uninterrupted data flow, which is obviously like a premium, right, when it comes to OT. And then there is obviously like the downtimes, data gaps, the duplication, and that makes it kind of like difficult to diagnose issues, right? And what does a resilient architecture ensure, right? That there is no data loss, there is guaranteed delivery, there is smooth kind of reconnection and buffering if like any connectivity is lost. There's that efficient use of the bandwidth and compute that can make sure that from an OT perspective, the core OT operations are not affected. So you can kind of like do things on top of that. That's what it's all about. And then when it comes to that, right? So this is where MQTT comes in, because MQTT is a data protocol, a data framework, which was created in the late 90s. It started with oil and gas, but it's become very ubiquitous with manufacturing and industrial environments because it's lightweight. It's publish subscribe, meaning like if we have data available and whatever your bandwidth is and connectivity situation, you can still publish data to a centralized broker in a small packet size. And then any subscribers that need to get that information can subscribe to it and get it. That's the key thing. So it's lightweight, it's reliable, it's bidirectional, and it's designed for devices with stateful context. So that's the great thing about MQTT. And then who we are, HiveMQ is a company that basically created its like business around MQTT. And so we are the most trusted MQTT platform that is transforming businesses with the power to connect, communicate, and control. So it's all about like connecting data, communicating it, and then controlling your IoT data. And we founded in 2012. We are currently in Series B. We got a funding of a total of 60 million euros with all our series. And then we have 5,000 plus companies that rely on HiveMQ to be able to be that like the data backbone that enables the data to move from their OT systems into IT systems so that they can do advanced analytics in a secure, reliable, and scalable manner. And so these are some of our customers. So this is kind of like our core platform. On the left, you have the devices. Obviously, Cisco provides the connectivity, the resilience from a cyber perspective, and the hardware, for example, to house it with the edge environment. We are a pure software play on top of that. We ensure that all of these devices that talk different protocols, for example, we can convert them into MQTT and then bring them into our centralized broker. And then we can kind of like consolidate the data with other pieces of information. So ultimately, you can support like your OT applications, for example, be it like data streaming or connecting that to a database or some custom applications. And we obviously ensure that this piece of software can either be on your premise or on the cloud, for example. And while doing that, we comply with all the security postures that customers want. And then so from a feature perspective, right? I mean, our four key components that we provide. The first is reliability. I mean, reliability is absolutely zero message loss, ensuring that the communication has no single point of failure. From a scalability perspective, we understand that you start small, typically like small number of devices, but you want to scale up to millions of devices that are sending the data back and forth. And so the system should be able to support that. And third is like we already talked about security. We also, MQTT itself is built with like a lot of security, but on top of that, we provide enterprise grade security when it comes to like data at rest and data in movement, data encryptions, so like certificate based authentication, access control, like secure access controls. And then obviously being compliant with MQTT 3.1, 3.1.1, and 5, and supporting all of the advanced features that MQTT provides. So when you look at our product evolution, we kind of like started as that IoT event backbone, if you will, right, with our pub sub and scalability and reliability functionality. And then we added the HiveMQ Edge because we felt that we really need to go to the source of the data and be able to kind of like get the data right from there. Either the data might be in like the OPC format, Modbus, or other PLCs that might have data in different formats, and then convert them to like MQTT topics, which are lightweight. And then we realized that, oh, that's great, but then we also need to be able to curate the data, if you will, right? If the data is not in the right format, for example, or the right quality, it needs to be curated. And then we need to be able to create this unified namespace, which we'll talk about in a little bit more detail. So to create that single source of truth, and then drive some actions out of that. So, and that's kind of like the evolution that we're going towards. So it's not just about just bringing the data and moving the data. It's about contextualizing it, and then it's about driving actionable insights out of the data. That's kind of like our evolution here. And then when it comes to unified namespace itself, the need for a unified namespace is because traditional systems, the factory systems, for example, they follow an ISA 95 model where you have data flowing from shop floor to top floor, but each layer is kind of like isolated from each other. And then the typical distributed architecture model is where each of these systems are connected to each other, kind of in a client server architecture model, and it's not efficient. It's not scalable, if you will, right? Very quickly you get the spaghetti architecture. What we are proposing through our unified namespace architecture is, and with the MQTT broker, is this hub and spoke model, where you have the centralized broker, and every sensor or every software or application or system goes through that in terms of like publishing data and subscribing to the data. So it's more efficient from a bandwidth perspective, and it is also easy to add new systems, for example, as new systems come in, or maybe when systems leave, it is easy to do that as well. And so what UNS does is like it takes your raw data, it creates information, and then it drives insights. And so that's kind of like the core functionality of a UNS. So there are some key things, and this is kind of like how UNS is represented, like typically following the ISA 95 model of your enterprise site area line cell, kind of like showing the data that is pertinent to what you're trying to do from a business perspective. And for example, in the filling machine cell, you have like these different alarms, like high pressure alarm, low pressure alarm, that you want to be able to track. And there are pieces of information coming in from your maintenance system, for example, or MES system, or other machine events. So it's not about like bringing all of the data together. It's only bringing the data that's pertinent to what you need to make your decisions together into the single source of truth, so that you can then use it to kind of like build your advanced AI models or ML models, or build your digital twins and other use cases. And the key thing about this is like everything needs to be edge driven, meaning like whatever your source of data is, that's kind of like where your cleansing and contextualization starts. It has to be lightweight, and it has to be event driven, meaning like as events happen or as some changes happen, that's kind of like where the data is flowing. So that is the core mantra, if you will, of this unified namespace framework. And that's one of the reasons why it's become very popular recently, because it is at its core very, very practical. And there's a lot of solution providers that have built solutions around it. And from our perspective, we feel that like using an MQTT broker, which at its core kind of like embodies a lot of the unified namespace concept, is absolutely important, because you need to bring together the data, and you also need to contextualize the data. You need to make sure that you have the metadata to go with the data as well. And so this is kind of like how it looks, if you will. So you have your local sites kind of like consolidating the data, and then ultimately your unified namespace kind of resides on that enterprise layer. And this is typically how it looks. And this is how the OT systems can securely talk to the IT systems in a very meaningful and contextualized manner. And when you look at the benefits of unified namespace, right? So we already talked about unifying data from OT to IT to create that single source of truth that reflects the true state of the business. It helps enhance decision making and makes it more efficient because you're not making guesswork, for example, based on data that may not be the most up to date, or data that is not the cleansed or consolidated or normalized. You're making decisions based on data that you can trust. It creates the scalable infrastructure, which is basically ensuring that as your data infrastructure grows, you're able to easily scale up, and then it allows you to provide that instant insights as your organization grows. And then also, like from a data hierarchy perspective, it clearly gives you like a hierarchy of where the data is, that helps you enhance the ability for you to govern the data and provide more context. It helps you kind of like bring data across like different applications and diverse platforms together. And last but not least, it helps you enhance your business performance, because at the end of the day, that's what it's all about. It's all about enhancing business performance. And looking at like real-time data intelligence. Now, not all data can be moved, or OT cannot move all of the data, but you still want to drive some business intelligence, right? So that's kind of like where this new platform that we have developed called Pulse comes in, where you have like a server, for example, that is sitting on top of our existing solutions, that has these different agents that can go and do some compute around like information, and then pull in all the results of that. Helps you build the unified namespace, and then you can start driving some insights. For example, if you want to do some trending analysis on your historical data, for example, or you want to drive some dashboards and things like that, that's kind of like how this Pulse rolls. And it has a elegant client that can show all this information visualization, or through APIs, it can provide that information to higher levels or other applications that can take this information and run with it. That's kind of like how this new Pulse works, and that is currently in private preview, and it will be available in Q3 of this year. So this is kind of like how the overall layer looks. And so we have this concept of well-architected systems, if you will, right? Where typically you want to kind of like have like a good way to like get data out of like each site. For example, you want to have an edge layer, and you want to have like a consolidation layer on top of it that consolidates the data in a single site. But then you want to be able to replicate and create that blueprint across multiple sites. And then you want to be able to cleanse the data. You want to have like high availability, for example, as you want to make sure that you provide that high SLAs. Then ultimately you want to bring that data to the cloud or data center, where you start processing, integrating, persisting, and you drive applications. And this is kind of like where the Pulse comes in and ensures that as you're trying to do that, if you really don't want to move data, or if you want to be able to derive insights wherever the data is, we can drive that through the Pulse. And last but not least, here is just a quick summary of like some of the capabilities. We talked about some of the capabilities already, like the cataloging, but Pulse brings in the additional historical analysis. Pulse makes your data AI and ML ready, so that you can start building models both at the edge as well as on the cloud. And it adds automatic IoT data streaming. And obviously it also has like real-time event driven architecture, which is basically the backbone of what we try to do as well. So this is kind of like how, from a data resilience, OT data resilience perspective, HiveMQ is helping customers out. So back to you, Greg. That's all I had.
Great. Thanks, Ravi. You know, that was a great overview of how MQTT and a unified namespace can really transform OT data management. Adam, any thoughts on that?
I think the key takeaway is that it's not just about collecting data, it's about making it accessible. It's making it reliable and it's actionable. So the UNS architecture, for me, it's a game changer.
Absolutely. So we've talked about the what and the how, but now let's talk about the why. Why is digital resilience so critical for manufacturers today? For that, I'd like to introduce Johan Jepsen, the digitalization and IoT expert at Orange Business. Johan, the floor is yours.
Thank you very much, Greg and Adam. Let me start sharing a few pictures of that. And I believe that to be working. So let's talk a little bit why we need digital resilience. Making the case. I mean, having a reliable infrastructure is, of course, becoming more and more important when we want to do things in a digital manner. And let me just speak a little bit about what we're seeing and what we need to do within manufacturing. I categorize things by three here. We quite often talk about Industry 4.0, we talk about digitalization, and we talk about industrial IoT. And I'd just like to a little bit establish what we mean with the different categories of digitalization that we talk about. So industrial IoT, we use sensors and we use software to move from looking at things historically to more in real time. And you can think about you're having a production line and you would like to see how it's performing in real time. That should be much more valuable and interesting, of course, than, you know, at the end of the week, we calculate how did we perform. And then we talk about digitalization, moving from paper to no paper, meaning we move into a digital format. And of course, we are depending on reliable and resilient infrastructure when we do digitalization. And it's so important to move away from paper, but it's quite common out there today that manufacturing is still operating by paper, collecting you know, quality measurements or machine status, or even taking notes about issues. And you know how we humans behave, we tend to forget or the details get lost. So it's much better that we do it digitally from the start. And then moving or turning data into information. This is actually the process of having individual data measurement points, but we're adding context. As already mentioned here on the webinar, the contextualization of data is so important. This is when we're adding more information to the data so we can understand where it comes from, maybe which machine, which production site, etc. This is the contextualization of data. And a little bit about the why we want to become data-driven is, of course, that we want to move away from understanding the results and the facts after it happened to move into a real-time understanding of what is going on right now. And the next step is, of course, to start predicting. So we would like to predict the result of our operations end of the week before the end of the week happens. And we would like to predict the result of this month before the end of the month hits us, right? Because that makes it possible for us to take proactive countermeasures. So I'm usually say that a happy plant manager is a good plant manager, and to keep your plant manager happy is to give them, you know, data and information ahead of time, so you can actually make them spend their time on the golf course and monitor that everything is fine. There is a lot of interest, of course, in data-driven manufacturing and digitalization. We have, as Orange Business, we're getting a lot of requests for predictive maintenance. We want to use vibration sensors to monitor our machines. But one of the, let's say, key understandings is that is this manufacturer or this customer or this plant already using traditional measurements like OEE and the traditional key performance indicators. And why that is so important to understand is that before you engage in some, let's say, AI-driven technology, you need to be feeding your analytics with good and qualitative data. That means looking at things like OEE and performance metrics that are well established in the industry might be a good place to start. This is the way to start your digital transformation, because companies not measuring OEE, they're typically performing maybe at the half of their capacity. So we take this three-step approach here just to understand where you are on your journey. We want you to at least start collecting the basic data and the basic information to derive the basic KPIs. What will an automation engineer or a plant do to furthermore improve their performance after you have established a well and good OEE? That is, of course, that you try to sweat your assets. You're using the same machine. Before you're building a new factory, you actually try to make it go faster. So if you're a car manufacturer producing 60 cars per hour, maybe you would like to do 65 before you start to build a new factory. So the second step in making your factory run more efficient is, of course, to try to run it more faster with the same quality. And if you do this in a sensible way, using the best available technology today, you start to collect data. That's going to be in your third step, so important to become the data-driven company who use data and information to analyze your operation. So there's a lot of fixing the basics out there still needed, but while you're fixing the basics, do it in a good way so it delivers you quality data that you can use for analytics. And as already touched upon, this is my version of the spaghetti diagram, and I think we all love to talk about spaghetti diagrams, because when you do data-driven manufacturing, when you're analyzing things, you immediately want to start integrating systems. You want to pull out the data from the silos. You have an ERP system, you have a SCADA system. If you're that type of manufacturer, some don't have SCADA, some don't have MES. But in the case you have, and at least we say you will at least have a PLC and you will have some sensors. But you might want to derive different type of analytics, maybe energy consumption per batch that you're producing, or per work order, or even per item. That means you need to understand what is a batch and a work order. That's something you pull out from your MES, but you also need the energy measurements. That would already make you integrate two systems. And then the next day you get a new idea. I want to do maybe a real-time rescheduling of my production schedule in real time. That will cause another interest in integrating to more systems. And as you go with your use cases, you create more and more on this spaghetti in the middle. That's why we said there must be a better way to have multiple of applications consume the same or parallel data to derive different results. And that is, of course, why we talk about the unified namespace. But before we talk about MQTT and the unified namespace, I want to show a quick demo. A quick demonstration of data collected in real time. It's a simple demo, but I will also demonstrate how it's running on top of Cisco equipment using the HiveMQ technology and a few other components in what we call an open architecture. In my line of work, I create architectures and I help manufacturing companies to integrate data and make use of data. This is a typical architecture. You will see PLCs and devices on the left-hand side. You will see software that converts protocols, and you will see something like HiveMQ Edge, which will help you to distribute the information in the MQTT protocol. Now, the demo is a little bit more simple. Therefore, I created this picture, of course. I have a PLC and I have an energy sensor. And these speak serial port protocols. They might be speaking Modbus or S7 or other PLC related protocols. We have a very common element here, KEP server, which will allow me to have all the native PLC drivers converted into an OPC UA server, for example, and I will utilize this in the demo. I will use OPC UA, and I will have HiveMQ's Edge product to subscribe to the data coming from the PLCs and the energy sensor. I will provide also a Grafana dashboard just to make it a little bit more visual and to show data in real time. But interesting enough, you at Cisco have started to provide your products with capacity for running applications on infrastructure. So here I'm showing a picture of, I believe it's a 9300 series device. And on that one, we have deployed an HiveMQ Edge and a Grafana container. So right there out at the edge in the network, in a segmented network, we can start deploying the technology that helps us to collect the data. And now let's move a little bit into the demo then. Now I need to switch window. Bear with me. Now I'll do the scary thing of sharing my screen. So, first of all, I will show you that I am actually running a KEP server instance on my Windows computer. This is the typical application. It's a typical application that you will find in manufacturing, typically running on a Windows PC or a Windows server. And this is the one we can connect to. It can be an engineering workstation even. And what I did is that I connected HiveMQ Edge and I understand it might be small, but it's not the intention that you need to see all the details. In HiveMQ Edge, it's an MQTT broker that you can deploy on the edge. You have something called protocol adapters. And in this case, I'm using a protocol adapter that speaks OPC UA and connects to the kept server instance. And I can map up the tags that I have in my kept server, and I can translate them into MQTT topics. So here is a graphical representation of what I have mapped today. I have speed and I have status and I have a few more tags that I'm going to transmit over MQTT. And just for the fun of it, everybody doing unified namespace and those things tend to show you MQTT Explorer. And here you can see the live data. You can see the speed of my production line, the power it's consuming, and status. These are just some simple data points I decided to collect. And I will then rapidly just move into the dashboard. And this is a live dashboard being fed by my PLC behind me here. So when I move my lever, you can see that my anticipator, or that actually my measured speed, changes. I have two data points here. I measure power consumption and I measure the speed, millimeters per second. This is of course a made up case, but it shows you what's possible even on top of infrastructure today. We can build much more sophisticated things, but this was just the point to show you data collected in real time and visualized in real time.
Mm-hmm.
And now I will continue with my presentation. So how to deliver digital resilience? In Orange Business, I work on delivering projects. But before we deliver projects, we also need to create the roadmap and the understanding of what to deliver. And there has been a lot of projects started maybe that you heard about in IoT world, so to speak, that didn't bear fruit. And what we are doing is that we focus on understanding the needs of our customers from a business perspective. Therefore, we have a number of different assessments that we can engage with. We have a flash assessment, which is about meeting the customer and observing their manufacturing, observing their operations, so we can give advice what's possible, what's lacking. But a more deeper assessment is what we call the factory assessment. It takes less than 10 days to turn around, maximum 10 days. We will visit the factory. We work with all the relevant and important teams in a factory, like the maintenance team, the operations teams, the continuous improvement teams, factory leadership, and plant engineering. Sometimes we meet with a couple of other groups like quality and so on. But the importance is that we give them a rapid or a short education on what is possible with digital transformation, what is the possible of the art. And what we're then doing is also collecting what they find challenging in their day-to-day work, what they would like to see improved. And by having that kind of assessment where we interact with the relevant groups in the factory, we can shape a plan together with them to define, for example, a pilot case, which is going to be business positive for them. We are not engaging in technology tests. We're engaging in proving the value to their operations, meaning we will engage in something that dramatically changes their efficiency. That's how we operate. Of course, you can then move into deploying a pilot or even scaling it up in a multinational manufacturer with tens or hundreds of factories around the world. Our customers typically have something between 20 to 100 factories. They, of course, need help to scale this up. Moving a good case into multiple factories. There is often a unique, let's say, tuning to use cases, but there can also be some kind of replication, because when you understand their operations, you can use that knowledge to improve also other factories. Now, what we see when we visit factories, of course, a lot of the traditional architecture where you have sensors and PLCs and SCADA systems, they were all built to solve a very specific problem. They were not built to share the data. And this is then creating the data silos. You have data in sensors you would like to touch, but it's very difficult. You have PLCs and you have the user interfaces. They also contain a lot of valuable information, but it's not easy accessible on the network, so to speak. And then you have your MES and your ERP and your cloud that hosting maybe the ERP. But all of those are point-to-point integrations, and they're not readily available to share the information. You need something in between, or you need something to change here. And that is why we as Orange and HiveMQ and Cisco has engaged in the unified namespace. What's so fundamentally different about the unified namespace is, of course, that it's a common technology that allows you to share information. So we're using MQTT as the protocol to contain or bear the information, but we call it also an information broker. This information broker can then be the speaking point to your ERP, your MES system, and the sensors. And once you mapped your data and information into the UNS, it can be accessed by multiple of applications at the same time. So there's not so much magic in it, but of course, there are a few practical things to think about when you deploy a unified namespace. And we here are, of course, ready to help anyone who wants to engage on a unified namespace, how to create it and deploy it. We mentioned a couple of times the contextualization of data. Here is our vision for a smart factory. You have all the legacy systems that starts to talk into this information broker. So we integrate systems, preferably only one time. And that one time is the point when you start to share the information from which you can drive high value analytics, meaning this is how you derive the analytics that changes your business, so to speak. Just a few words on contextualization. It is one of those words that sounds much more difficult than it actually is. When we contextualize data, we're showing an example here at the bottom right. You have a PLC, and a PLC was never programmed to have a lot of information about the data. It may have very raw measurement points. And what you will see here, 40,001, is just an address in the memory of the PLC. And here we're measuring a pump pressure. So when we're contextualizing data, it means we're adding understanding, human understanding to the data. So that's the contextualization process. You're adding information so that humans can understand the data. And that is actually how you're enabled to have data scientists and analytical people in your company helping you out to derive information and derive results from your data. A little bit more of a graphical representation of the challenges in the manufacturing. I'm going to apply the X-ray on a factory here, the OT and the IT environment. And what you will tend to find is this myriad of connections. This is the spaghetti that we typically have between devices like PLCs or line interfaces, MES systems, etc. This is what we see when we X-ray a brownfield and an existing factory. Therefore, we have this vision of the modern factory, where you have the unified namespace helping you to collect and share data that will be feeding your if it's generative AI or AI applications or traditional business intelligence. You have a much more clean architecture here now where data is flowing freely. And that is how Orange helped to deliver digital resilience.
Excellent. Thanks, Johan. Thanks very much, Johan. I'm just going to take the share here. So wow, Johan, thanks so much. That was fantastic overview of how Orange Business is helping manufacturers navigate the complexities of digital transformation. Hey, Adam, what are your key takeaways from Johan's presentation?
Yeah, I think Johan really nailed the importance of having a partner who understands both the technology and the business challenges of manufacturing. It's not just about implementing the latest gadgets, it's about understanding the specific needs of each manufacturer and tailoring solutions to meet those needs.
Absolutely. And the real world example that Johan shared really brought it to life. That X-ray was quite amazing, sort of the before and the after. It's one thing to talk about digital resilience in theory, but it's another to see how it's actually being implemented and the impact it's having on business.
Yeah, it's clear that like digital resilience is like no longer a nice to have, it's a must have for manufacturers who want to stay competitive and to stay secure in today's rapidly changing environment.
Agreed. Definitely agree. So we've talked about the what and the how, and Johan has given us a great understanding of the why. And now let's dive into how HiveMQ, Orange, and Cisco are working together to deliver digital resilience. Robbie, maybe you can start this off.
Yeah, sure, right? I mean, like, and I think it already came together, right? I mean, from our perspective, we are kind of like the providers of the data backbone, the MQTT platform, if you will, that helps you not only move data efficiently, but also help you contextualize it, ensure that it's real time from edge to cloud. And then also like if the data doesn't need to move, then have that like a pulse solution, if you will, on top of it that provides you the ability to derive insights and create that unified namespace. That's kind of like our thing, right? We're good at that data piece and ensuring that everything comes together from that perspective. Right? And maybe Johan can chime in, obviously, where Orange comes in.
Yeah, I'd love to. I mean, we as Orange, we act as the system integrator. We have focused on having the let's say manufacturing knowledge in my team. We understand what a statistic process control is. We understand the challenges on a factory floor.
Right.
But to really help a manufacturer move into a data-driven and a more digital world, you also need to have a lot of IT expertise.
Right.
And you also need a lot of reliable applications and reliable infrastructure because, you know, manufacturing is a little bit like black magic. There's no one who's very appreciative if your production line has a lot of stops and starts, right? So when you're moving from paper to digital, it is the same expectation that your digital tools will be there always and reliable. And that's why we also choose to partner with HiveMQ, because you have some of the most reliable and best, let's say, infrastructure for moving information on the market. But it's not enough to be able to buy that, let's say, application. I also want to have the relationship on a deeper level with the partners I work with, because we're going to see a rapid change in adding functionality like the Pulse product that you're bringing to market.
Right.
And I don't think we're able to really predict what we're going to have in 5 years. So it's important that you have partners who can move as technology improves.
Absolutely, Johan.
Yeah, and I think that's exactly right. And I guess from Cisco's perspective, we're providing the underlying infrastructure, the industrial networking portfolio, the security, and the edge compute capabilities. So our industrial switches and routers are designed to withstand harsh environments and provide the reliable connectivity that OT systems require.
And, you know, it's not just about the individual components, it's about how they work together. For example, we're seeing some really exciting kind of innovation happening really with the Hive Edge MQ running in Cisco IOX, which is the edge computing hypervisor and environment on our industrial switches and routers, and also on the Catalyst 9300 that Johan mentioned, also has the hypervisor capabilities to host applications. So Johan, I know Orange is actually piloting some of that with a customer. Is that right?
That is right. I'm not able to reveal who the customer is, but fun enough, we're engaging in of course deploying HiveMQ Edge to do data. It's a little bit simplification to say data collection, but attaching to data sources and bring them to applications, right? Inside Cisco infrastructure, and Orange is then the partner is also managing the infrastructure for the customer. So we're kind of end-to-end responsible for delivering infrastructure functionality like connectivity in those factories and between those factories and offices, but also now adding application responsibility between our operations team. So it becomes a little bit of a one-stop shop for the customer. You have one partner who's responsible for infrastructure to transport packets, but also now to transport information.
Great. And yeah, so I think it's just the true integrated solution from network to data to cyber. And that's kind of like how we come together. We are all focused on helping manufacturers achieve that digital resilience in a really practical and scalable manner, right? And that's how, to me, HiveMQ, Orange, and Cisco come together in a meaningful manner to really solve customer-specific issues in the industrial world.
Exactly, and it's really about bringing together that best of breed technology, what HiveMQ is doing on the whole data resiliency point, what Cisco is doing with the connectivity and the cyber resiliency point, and then bringing in that deep industry expertise that Orange Business and brings to the table. That's really that global reach to help deliver the real results for our customers. So, guys, that's really kind of bringing us here towards the end of our presentation today. I wanted to take a quick look to see, we've got a couple minutes left. We may have some Q&A available out there, but before we get to that, so just want to say, hope that you found, everyone on the call, that you found this informative. We've covered a lot of ground today, from the connectivity to cyber security to data resilience, and we heard from experts at Ravi at HiveMQ and Johan at Orange Business. Adam, what do you think?
Yeah, I think the key takeaway for me is that digital resilience is not just a nice to have, it's a must have for manufacturers who want to stay competitive, efficient, and secure. Thanks.
Yeah, absolutely. So now we're gonna let's do a bit of the Q&A. I think we got a couple minutes left. Mike, do we have any questions out there that we might be able to answer real quick?
We do. I'm going to try and pick one out for each of you, because I'm just looking at the clock. Ravi, can we start with you? I've got a question from David. Can you tell us any more about different protocol adapters available in HiveMQ?
Yeah, real quick. So for us, it's all about like the 80-20 rule, right? So we work on protocols that are used in 80% of the cases. Obviously, the big ones for us is OPC UA. That's the major one. And we actually support bi-directional OPC UA now. And then the other one is Modbus. And then like, obviously, we cannot forget about our PLC friends like Siemens and Rockwell. So we have Siemens S7 as well as like Rockwell protocols like the Allen Bradleys. And then we recently, actually very exciting, we just launched Empty Connect, which helps us with the CNC operators and how you can track and all that, right? So those are the protocols that we build. We also have like an SDK that customers can use to pull in any other protocols that they may have built, and maybe Orange and other partners can build protocols as well. So it's fairly straightforward from that perspective.
Thank you, Ravi.
Thanks, Mike.
One for Cisco. Adam, I've got a question from Henrik. You mentioned earlier on assurance to ensure the systems are doing what they're supposed to be doing. What does that look like?
Should I pick that one up? Yeah, so I'll pick that one up. So what that means is in tools that we've got that help to manage and automate the network, we have an assurance capability kind of built into that. And there's assurance can happen at both the hardware level as well as sort of a network service level. So for example, you can assure that if you've got wireless access points and Wi-Fi that's in a manufacturing environment, and in a certain area of the network, you're seeing a lot of dropouts happening and clients aren't able to attach, the assurance will be able to pick that up and help then provide guided troubleshooting to kind of help deal with that. In the same way, there may be a problem that happens just with kind of straightforward connectivity, maybe, within a ring that's in the manufacturing setup in a ring topology, you may have had a failure that happened. You need to understand that a little bit better. Assurance will help to dig down to say, hey, here's what's actually happening in the network, and again, provide you sort of an automated workflow to help deal with that in a troubleshooting kind of way.
Thank you, Greg. Let's pick one more for Orange. Johan, this is for visibility and environments. How is the transformation presented? Is it presented in documentation or a workshop after the discovery sessions?
All right. So about our assessments, they are They are performed live on the site, of course, and with a recapitulation of the findings while we're on site. Then we take about 1 day to create a report with prioritized actions and suggestions or recommendations to the customer. And we are, of course, doing a live presentation of the findings. And then there can be more of a conversation also with the customer if there is something they would like to have reflected differently. But I think what's most important is that we are creating a written report of the findings and with the prioritized suggested actions, meaning that can be, you know, we can even identify, of course, infrastructure things like that impact security and how things are built on the factory, and together with data-driven manufacturing outcomes. But yes, written report, prioritized actions.
Thank you, Johan. I think, Greg, we've reached the clock's beating us, right?
Yes, that's right. That's all we've got time for today. So thanks everyone for attending today. Thank you, Adam. Thank you, Ravi. Thank you, Johan, for sharing your expertise.
Yeah, and thanks to everyone else for joining us today. Yeah,
Thanks everyone. Bye-bye.
Thanks for having us.
Thank you.
And panelists, please stay on. But anyway, we'll be sending out a recording of the webinar and the presentation and all slides of all the slides presented to the attendees. So everyone, all the attendees, have a great day. And panelists, once again, please stay on.
Thank you for joining, everyone.